A few years ago, if someone told you that a single battery could change the future of electric cars, most people would have dismissed it as another ambitious promise. The EV industry has heard plenty of those. Bigger range, faster charging, lower costs, safer batteries. Every few years, a new breakthrough appears, grabs headlines, and then quietly disappears into the background. But this time feels different, because behind the latest promise isn't a startup looking for attention. It's Toyota. And Toyota isn't making a small claim. For years, the company has been working on a battery technology that many engineers believe could solve some of the biggest frustrations electric vehicle owners face today. A battery that could charge dramatically faster, a battery that could store more energy while taking up less space, a battery that could potentially last longer and operate more safely than the systems powering most EVs today. The technology is called a solid-state battery at first glance. That name doesn't sound revolutionary. In fact, it sounds surprisingly ordinary. But hidden inside those two words is a question that could determine the future of transportation. Can one change inside? A battery completely reshape the electric car industry? What's interesting is that Toyota didn't arrive at this moment the same way many competitors did. While much of the automotive world rushed toward fully electric vehicles, Toyota took a different path. Instead of betting everything on battery electric cars, the company spent years focusing on hybrids. It wasn't because Toyota didn't understand EV. It was because the company believed something many people ignored at the time. Technology is only useful when the real world is ready for it. Charging infrastructure varied dramatically from country to country. Consumer habits were different. Electricity access wasn't equal everywhere. Toyota believed a hybrid solution could bridge that gap. For a long time, that decision was criticized. Some analysts claimed Toyota was falling behind. Others argued the company had missed the electric revolution entirely. But while critics focused on what Toyota wasn't doing, Toyota was quietly investing in something far more ambitious, something most people never saw. And that hidden project would eventually become one of the most talked about battery programs in the world. But to understand why it matters, you first have to understand the problem Toyota is trying to solve. Today's electric vehicles are powered primarily by lithium-ion batteries. They are the reason EVs became practical in the first place. Without them, modern electric cars wouldn't exist. They're powerful, reliable, and capable of storing large amounts of energy in relatively compact spaces. But they come with trade-offs. Every EV owner knows them. Charging takes time. Battery packs are heavy. Performance slowly declines over years of use. And because of the materials inside them, these batteries require sophisticated cooling systems, sensors, and safety controls to operate reliably. None of these problems are deal breakers, but together they create limits. Limits on range, limits on convenience, limits on how far electric vehicles can evolve using today's designs. For years, manufacturers have tried improving lithium-ion batteries. Little by little, slightly faster charging, slightly better energy density, slightly longer lifespan, but Toyota wasn't looking for a small improvement. The company was looking for a leap, and that leap centered around a component most drivers have never even heard of, the electrolyte at first. It sounds like a technical detail that only engineers care about, but this tiny component controls something incredibly important. Inside every battery, lithium ions move back and forth between two electrodes. That movement is what stores and releases energy. The electrolyte acts as the pathway that allows those ions to travel. Without it, the battery simply doesn't work. For decades, lithium-ion batteries have relied on liquid electrolytes, and that approach works. But it also creates limitations. The liquid requires protection, it requires cooling, it requires additional systems to keep everything stable and safe. Toyota's idea was deceptively simple. What if the liquid disappeared? What if that pathway became solid instead? On paper, the change sounds almost insignificant. In reality, it could alter everything. Because once that liquid is replaced, the entire architecture of the battery can change. And this is where the story starts to get uncomfortable. The reason so many experts became interested in solid-state batteries wasn't because they offered one advantage. It was because they appeared capable of offering several advantages at the same time. Higher energy density, lower weight, improved safety, potentially faster charging, potentially longer life. In engineering, Improvements usually come with compromises. You gain one thing and lose another. But solid-state technology seemed to promise gains across multiple categories simultaneously. If those promises proved true, manufacturers could potentially build vehicles that travel farther, without increasing battery size or maintain the same range, while reducing weight, and that possibility triggered a race that is still unfolding today. Because once a technology appears capable of changing an entire industry, every major player wants to be first. But here's the part most headlines leave out. Building a revolutionary battery in a laboratory is one thing. Building millions of them is something completely different. And that's where the real battle begins. For decades, the automotive industry has learned a painful lesson. A breakthrough isn't real when it works once. A breakthrough is real when it works millions of times. Every battery that ends up inside a vehicle must survive years of abuse. Heat, cold, traffic, fast charging, long road trips, daily commuting, unexpected failures. Real people don't drive inside laboratories, and real roads don't care about engineering presentations. That's why Toyota's biggest challenge isn't inventing a solid-state battery. It's proving that one can survive the real world. The first obstacle appears almost immediately. Manufacturing. Today, single quotes as lithium-ion batteries benefit from decades of refinement. Factories around the world already know how to produce them. Supply chains exist. Machines exist. Workers know the process. The entire ecosystem is built around them. Solid-state batteries change that equation. Different materials often require different production methods. Different production methods require different equipment. Different equipment requires new investments. Suddenly, the challenge isn't just technological, it's financial. A company could create the greatest battery in history, but if it costs too much to manufacture, most customers will never see it. And that's where many promising technologies stumble. Not because they fail technically, because they fail economically. Toyota understood this from the beginning. The company wasn't simply trying to make a better battery, it was trying to make a battery that could eventually be produced at a scale large enough to matter. And scale changes everything. Making one prototype is difficult. Making 1,000 is harder. Making 1 million without defects is a completely different problem. Even a tiny manufacturing inconsistency can create massive consequences when multiplied across millions of vehicles, which raises a troubling question. What happens if the battery performs perfectly in testing, but becomes unreliable during mass production? That possibility keeps engineers awake at night because battery technology isn't judged by its best performing unit. It's judged by its worst one. And Toyota knows that better than most. Years of research led to prototypes. Prototypes led to testing. Testing led to more revisions. Yet despite all the excitement surrounding solid-state batteries, Toyota continues to move cautiously. Not because the company lacks confidence, because confidence isn't enough. Proof is. And every month that passes without a large-scale launch reminds the industry how difficult this challenge truly is. But while Toyota wrestled with these problems, something unexpected happened. The rest of the world started chasing the same goal. What began as a research project slowly transformed into a global race. And suddenly, Toyota wasn't running alone. Samsung started investing heavily in next-generation battery development. Nissan accelerated its own solid-state efforts. Honda began building demonstration production lines. Mercedes-Benz formed partnerships to test advanced battery systems. Hyundai and Kia entered the conversation. Volkswagen-backed projects pushed aggressively toward commercialization. Even CAT Alpha, world's largest battery manufacturer, began exploring multiple alternatives simultaneously. Not because every company believed solid-state batteries were guaranteed to win, but because nobody wanted to be the company that missed the next major shift. History has a way of punishing hesitation, especially in technology. The smartphone industry learned that lesson. The computer industry learned it, the internet taught it, repeatedly. And now the automotive industry faces its own version of the same question. If solid-state batteries work, who gets there first? Because being first doesn't just mean selling a better product. It means defining the standards everyone else follows. But this is where the story becomes even more interesting. The companies involved aren't actually competing to build the most impressive prototype. They're competing to solve a much harder problem: trust. Consumers don't buy battery chemistry, they buy confidence. confidence that their car will start every morning, confidence that charging won't become a daily headache, confidence that the battery will still perform years from now. And this is where the entire future of solid-state technology could be decided. Not in laboratories, not in boardrooms,